Hi 3M, we're on lesson 5 of financial math, and we're going to talk about present values of annuities. So a retired hockey star wants to set up a scholarship fund to assist an underprivileged child who would like to go to a post-secondary institution. He wants to ensure that the child will have $6,000 per year for 5 years. How much should he give the institution now to ensure that this can happen if the institution is able to invest the money at 10% compounded annually? So I know this is some type of an annuity because what's going on here is that there's an amount of money per year for a while. So there's a regular payment happening over and over again. It's not a one-time deal. So we would call that an annuity. However, this one, we are not saving towards an end goal. We're not putting money away every month to get a large sum in the end. We want to invest something now to be able to pay this child out over the course of a number of years. So we call this a present value when we need a certain amount of money now in order to pay out over and over again. So what we want to have is a certain amount now that a year from now, this person will get $6,000, and then a year after that they will get $6,000, then a year after that, and again and again. So it looks like he needs about $30,000. But remember, he should be able to invest a little less than that because he's going to earn interest on that money as it sits in the bank. So we would like to figure out how much money he needs now. What the banker does is he takes the first $6,000 and says, you know what? If I want to figure out the present value for that $6,000, I use my formula from 2 lessons ago, I'm sorry, where we take our $6,000 and we say, what present value do I need for that one? If it sits in there for 1 year, my interest rate, I just have to find it, is 10% compounded annually. So at least that's simple enough. To find the present value for that one, we do a division. And so for the first payment, he would have to have $5,454.54. So that first amount of money would earn a little bit of interest, and the student would get $6,000, year number 1. For the second payment, he wouldn't have to put in quite as much as $5,454 because it has 2 years to collect interest. So I am just doing each one of these payments separately just to show you where the numbers come from. So what principal will he need to put in there for the second one? I'm going to do 6,000 divided by 1.10 squared. That would be a principal of $4,958.68. So we'd invest less than the last time. The next one, how much would we have to invest to get that $6,000? $6,000 equals the principal that I put in for it times the interest rate for 3 years. I'm going to divide by both sides by 1.10 to the power of 3, and I would get $4,507.89. 2 more. I would continue in the same way. How much do I need for that one? $6,000. How much for 4 years? That principal would be $4,098.08. So he's going to get over $1,000 interest on that particular investment. And the last, to get the last $6,000, he'll have to invest even less. 1.10, and it's going to wait for 5 years. That would be $3,725.53. So if I take all those bits separately and I add them all up. The total that he would have to invest would be $22,744.72. He would have earned quite a bit of interest in those years and been able to pay that student out $6,000 a year. There is a formula to do all of this in one step. It is kind of ugly, so I'm going to haul it out here and let you have a look at it. This is the present value of an annuity. You just move down a little bit. Okay, it won't. And some of those key definitions are the same. Well, that wasn't very nice to me. All right, the present value of an annuity is the regular payments you would like. This has a square bracket as well, but it looks a little backwards to the last one. One subtract 1 plus the interest rate to the negative n over I. So I'll let you write that down. P is the present value of the annuity, and the other letters we have seen before. Suppose you have an investment account that pays 5.5% compounded semi-annually. That's so I can find it. You wish to withdraw $350 every 6 months for 3 years. What is the present value of the annuity? In other words, how much do you need in the account right now in order to pay yourself out over the course of the next 3 years? That's an annuity because it's regular payments of any sort, and it's a present value because I need to know how much money I need now in order to pay something out. So we need to use that formula. Let's write it down. P equals R. 1 is subtract 1 plus I to the negative n. Again, all over I. How much do I need now? If I want to regularly withdraw $350, I need an interest rate that is 5.5%, but it's compounded semi-annually. So I'm going to change that yearly rate of 5.5%. So that's 5.5% as a decimal. And I'm going to divide it in half because it's a semi-annual rate, which we've seen before, which is 2.75%. My n is also going to change. It is every 6 months for 3 years. So 3 years, twice a year, there will be 6 compounding periods. So into my equation they go. Decimal 0.275 to the power of negative 6, square bracket all over, decimal 0.275. Please take a moment and work on this with your calculator. There's an awful lot of brackets, and that negative exponent can be a little bit tricky. We don't want to write down an awful lot, or we'll make a lot of rounding errors, and I would be glad to help you with your calculator. Your present value, when all the smoke clears, should be $1,911.83. Sue needs to borrow $7,500 to purchase a used car. The car dealer arranges with a finance company to lend Sue the money at 2.9% compounded monthly for 3 years. What will Sue's payment be? Sue wants some money now. That's a present value question, and she's going to pay it off regularly. That's an annuity. So this is a present value because she wants the money now and will pay it off. A number of you own vehicles and you know that if she is borrowing $7,500 and is paying it off, she will be paying the finance company back more than $7,500. She's going to have to pay them interest. So we want the present value formula. I have to check it too because it's a little weird looking. Okay. She wants to borrow $7,500, so that is the present value we need. What we want to find out is what is her regular payment. Oh no, not this again. 1 subtract 1 decimal. I want my interest rate, which is 2.9%, but it's compounded monthly, so it's going to be an icky little decimal. Decimal 029 yearly rate divided by 12. So our interest rate will be decimal 0024. The n is how many times it's compounded, and it is compounded monthly for 3 years. So there will be 36 payments, 36 compounding periods where interest is added to that account. So into the equation they go. Decimal 0024 to the negative 36 all over decimal 0024. Okay, carefully now. I'll try not to get my decimals in the wrong spot. I want to get r by itself. I want to get rid of that decimal 0024 by multiplying both sides by decimal 0024. So that will get rid of that. And I now have 18 on the left side equals r times this ugly business. I am going to divide both sides by ugly bracket, and I will, subtract 1.0024 to the negative 36. Very carefully, I type it in my calculator, and I will get $219.22. Does that make sense? If you have a fairly cheap car, and you're going to pay it off over the course of 3 years, that your payment would be $219.22. That seems reasonable. Let's see how much interest she pays. So if she pays $219.22, she pays times, and how many payments did she make? 3 years for 12 years. She is going to make 36 payments. So what came out of poor Sue's pocket is $7,891. You silly smartboard. Let's try that again. And 92 cents. And the vehicle was listed, I don't know why it does this, $7,500. So she paid $391.92 to have that loan, which isn't such a bad deal when you think about it. You got the privilege of buying a car when you need to buy one. Now, my friends, we need to practice.